Hello, this is the lecture for Wednesday, the 23rd of November, the day before Thanksgiving for Comp Sci 201, Section 60 in the fall 2022 semester. What I want to do is go through Jupyter notebooks and some things that you're going to have to know for Project 3. So we will start sharing Chrome. These are the slides that are available on the class GitHub. Fix that typo, and we'll start working. Okay. Jupyter, spelled with a Y, which I'll explain in a minute, but pronounced Jupyter, is a open source, freely available tool that lets you use Python or other languages, but we're Python, to prepare a research report with live Python code running to perform data analysis and provide graphics showing your results. I traditionally have students in this class do their Project 3 in Jupyter because it's something you can take with you. You can then use the skills you've learned in this class to do research, prepare reports, etc., in any other class that you have. Now, warning again, this is most definitely not something that the major sections are doing. It's going to be very different. Why? Again, this is a class specifically for non-majors, and so we want to give you something practical to take out of here. We want to show you that the computer science skills you've picked up will apply to whatever field you have. So we're going to work through some examples of this. The key site to go to is jupyter.org. Now, Jupyter is actually an amalgam of three different languages, Julia, Python, and R. And you can run Jupyter notebooks in any of those three languages, but of course we'll be using Python. R is a language for big data statistical analysis. It derives from a language called S that was done for statistical analysis. I've used R in data science. It's pretty mathematical. We won't go into Python as much more general purpose. A note on this is that Jupyter Notebooks presumes you have a high quality graphical user interface to present your results. gl.umbc.edu does not have such a graphical user interface. It's a command line driven system, as you've seen throughout this semester. So you will be running Jupyter on your own computer and you'll be submitting it to me when you're done. I'll give you details on that. If you do not have access to your own laptop or another computer that can run Jupyter, let me know immediately so we can make arrangements for you to do this Project 3. Okay. Typically, I will expect you to be doing this on your own computer and then submit it when you're done. And I'll show you how to do that. Now, what I want to do is give you some demos. So we'll go to jupyter.org. It looks like this. And if you scroll about a third of the way down the page, we're going to skip Jupyter Lab. We'll go to Jupyter Notebook. This is the tool that we're going to be using. Now, you can run it directly in your browser, or you can run it on your laptop. And we're going to start by showing how it works in your browser. So we'll click Try it in your browser. You will see this page. You will go again to Jupyter Notebook, click on that item, and you will see an interface pop up in a minute. That looks like this. Okay, and you'll see a background. This actually is a Jupyter Notebook that provides all this detail, but we're going to start another one of our own. So what we will do is we will click on File, New, and we want a new notebook. And another tab will open in your browser. Now, as is usual, when I do demos in this class, I happen to prefer Chrome, so all the demos are in are run on Chrome. It works very similarly if you're in Safari or Firefox or Edge. I'm also on a Mac. It works very similarly on Windows. We'll talk about that in a minute. For this, I want to select my Python kernel. That's just the version that shows other things that you can run. We're just going to select Python. Now, what you will see is this. This is what's called a cell. A cell is a unit in a Jupyter notebook that contains either Python code or what's called Markdown for instructions. Now, as we work through this demo, I want to go back to the slides and I want you to focus on things we're going to talk about because you're going to need to know this too. One is how to create a new notebook. We just showed you how to do that. To create a new notebook, you click File, you click New, and you click Notebook. Okay, that's going to be started. We're going to show you how to add cells. A cell, again, is where you put either code or markdown. We're going to talk about the different types of cells and what they're used for and how you use them. We're going to talk about how to run the cells, how output is handled, and how to run all the cells in a notebook. So let's go back to where we were in our new Jupyter notebook. Now, I want to use, I need to open one more tab. That's Markdown cheat sheet. I'm going to make this first cell the simplest possible case we can. Remember when we first learned Python, when we learned any language, the first thing we want to do is make the computer print hello world. So I will type Python code in this cell. You can see from right here that this is currently considered to be a code cell. This is a place you type Python code. So I will type Python, any valid Python that you've seen before, and I will say print hello, comma, world. And now to run this, I can either come up here to where it says run, or in this menu bar above, there's a little triangle like the play icon, and it runs the selected cells in advance. So I will click on this and it runs my cell that has the Python code hello world. And here is how the output is handled. So I wanted to show you how output is handled in Jupyter notebooks. Output is just printed directly below the cell. Now, what if I'd made an error? What if I had accidentally left off the closing parentheses? So this is a syntax error in Python. This code cannot work. And I try to run the cell here. What I get is an error message. Sometimes useful, admittedly, sometimes not. The error message says there was never any closing parentheses. So if you run a cell and it doesn't work correctly, you're going to get an error message, and that's going to tell you to go back and fix that cell. We'll put our closing parentheses back. We'll run it and we see it works. Now, the beautiful thing, one of the many beautiful things about structuring a Python program in a Jupyter notebook is the cells are independent. So if there's an error in one cell, the rest of the program will work. You can debug, you can test, you can make sure you've got what you needed. You don't have to look at an entire program that fails because of one error. Okay. Now we're going to run another Python code cell. When you run one, normally, depends on how you set this up, but normally it will Jupyter will add another cell ready for you to enter things in. If it does not enter a cell, if you look over here to the right, you will see a bunch of icons that have options. This is how you insert a cell below where you currently are. This is how you insert a cell above where you currently are. And so you can move about and add things if you need to. What I want to do now is write a Python section that's a little bit more complex. Okay. I'm going to do the problem we had on the exam, which is, and Python comments work the same way. Write nested loops that create a two-dimensional list of the first 20 cubes. And to clarify, 0 cubed through 19 cubed in a list with 4 rows and 5 columns. So here's the Python code to do that. Start with a new list, call it cubes equals, it's an empty list. This is standard Python, right? For I in range 4, because we're going to have 4 rows. And again, this is a mini IDE. This is not a full IDE like PyCharm that has all the features, but it does have a lot of nice Python features in it, and it will automatically indent as you're typing code. So you should be able to keep your indentations straight. And indentation is only relevant within a specific cell. Okay. So for I in range 4, remember, new row is going to be a new empty one-dimensional list. For J in range 5, because I'm going to have 5 columns, new row dot append, and what I want to append is the row number times 5, and I'm going to put parentheses to keep my arithmetic correct, plus J, and I want to take that cubed. And that closes the parentheses for the append. Again, if I'd left off that parentheses and tried to run this, it would tell me, there's a syntax error. Now, when that's done, I will append the whole row. And now that I'm done, I want to print out the whole thing a row at a time. And so I will do this for I. Let's use another one just so we don't get confused. I could safely reuse I, but I'll use K just to keep things simpler. For K in range 4, print cubes sub K. All right. So now what do? We're in this. We go back up here. We click on this to run the cells in advance. This runs the cells. Here is our two-dimensional list: 0 cubed, 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7, 8, 9, and so on up to 19 cubed is 6,859. 20 cubed would have been 8,000 if we'd gone to that. So you can see here that Python is running exactly as it did in the traditional programming we've done to date. There's nothing special to add or delete. You just write your code and you run it. And if you've made an error, it will tell you that you've gotten an error. Printing is printing to a screen. You can certainly print. You can certainly write to a file if you wish. That's not a problem. Any Python we've done before, and this is typically, depending on how you set it up, going to be Python 3.7 or 3.8. So you should not have an issue with any of the Python that you've written before working in Jupyter. Now what we want to get to is Markdown. Markdown is a way to document what you're doing. Okay, we want to document what we're doing. So to create a Markdown cell, what I will do is I will select Markdown, and that says this is no longer Python code. This is a cell we're using to document things. Markdown is a language. It's a pun. It's a play on markup. Obviously, when someone gives you a document, you mark it up, you edit it, you say, make this a heading, make this a bulleted list, make this a numbered list, indent, unindent, what have you. Well, you mark down. And so you type text and you tell Jupyter or another application how to represent it. Now, I've given you a link in the lecture notes to a very good cheat sheet or a reference that tells you what the syntax is for Markdown. And you can see, for example, that headings are indicated with the hash sign, with a hashtag. One hashtag, it's what's called a header one. This is going to be similar to Microsoft Word or Google Docs or something else. Two hashtags for header two, three for three, and so on. If you want to bold text, you use the double asterisk. If you want to italicize the text, use a single asterisk, block quotes, ordered lists, bulleted lists. Unordered lists are bulleted lists. This is a good reference for how to create nice, legible text. Now, so here's a markdown cell. This is a header level 1. And I will describe something useful. We don't want to say that, so let me backspace over that. And what I want as my top level header is description of the previous cell. Okay. Now I start typing text. The previous cell contained Python code that created a 2-dimensional list with 4 rows and 5 columns. The list contained the first 20 perfect cubes. That is the cube of 0, the cube of 1, and so on up through the cube of 19. Header 2, how we did it. We used nested for loops to execute, to solve this problem. We created, and let's make an ordered list. Going back to the cheat sheet, an ordered list is just 1, 2, 3. So we'll say 1, we created a new empty list to be our 2D list. 2, we created an outer for I loop to create each row. 3, we created an inner for I loop to create each element in each row. That is each column entry. Now, what you see if you're working on a markdown cell, if you're creating a markdown cell, what you're doing is you are simply typing text. If you want to see what this looks like when the markdown gets executed, you simply come up here to the run button, and this will run a markdown cell. And now you can see what happens when markdown is created. We've got our heading 1, which is automatically created when you run the markdown. That's what happens. When you do a heading 2, this is what you get. Here is your normal text, and here is the ordered list, the numbered list of items that we created, and Jupyter automatically created this by running our markdown. So you actually do run all cells in your notebook as you go through this. Okay, so this is just running in my browser. It's running in Chrome. It's saving. It's being checkpointed. It's untitled. I can change the title. This is going to be November 23rd demo. Now, this is not a Python program. a Jupyter notebook is not a Python program. So it does not end in .py. It doesn't end in .py. It ends in .ipynb. So remember that that will be the name of any program you create. Any Jupyter notebook you create will have an ending of .ipynb. The reason for that, well, it wasn't originally Jupyter notebooks. When it was first created, probably about 8-10 years ago, it was called IPython. Somebody decided, iMac, iPad, iThis, iThat, even though it wasn't from Apple, it was IPython. And so they were IPython notebooks, and that's where .ipynb comes from. It was IPython notebook. Project Jupyter took over IPython, and that's changed the name. But by that point, you can't change the ending. You can't change .ipynb. It's too ingrained in the community. So we will rename this, and now you can see that this file is called November 23 demo.ipynb. Okay. And this is what happens when it is run. Okay. And we can continue adding cells. We can also move cells. If I go to this cell and I can look at this, it says move cell up. So let's move this cell up. And now I can reorganize. Description of the previous cell is actually described. It's simply changed the order of my cells. And so the description, the markdown description, now comes before the actual Python description. Okay. So if that's the case, then I'm going to have to come in here and I'm going to have to edit this. And so I will come back here into my edit options, and I can do this. I can if I double click into the cells, the easiest way, by the way, changing that. If I double click on the cell, that gives me back to the raw unrun cell, and now I can easily edit this. That's not the previous cell, it's the following cell. I edit my markdown. And now if I run it again, I can see that if I pick the run option, I can do this. That's the same as clicking on the triangle, the play button. And now you see I've changed it and I've got everything here. So this is the simplest way to create a Jupyter notebook and start working on it. And this is what you're going to do in Project 3. The advantage to this, again, is we have Python code. We run it. If I wanted to create a markdown cell here, I just come back up and say, create a cell above this. This is my new cell. Instead of being code, it's markdown. And I say, the following cell is our first Jupyter code cell. It simply prints hello world. Always want to put that extra W. Then I run that cell, and now we have it. So the advantage to this as a tool is that it is something very useful that allows you to do reasonably fancy documentation of what's going on, along with reasonably complex Python code. This can be as big or as little as you want. This can be hundreds to thousands of lines of Python code. This can be just a few things. It's a nice tool that lets you put in code and description for whatever field of study you have. Okay, if you wanted to do a research report with Python inline that can be executed at any time using straight Python, you would have to write a bunch of block comments like your header comment or your function comment. If you wanted to do something else, just standard, a Word or a Google Doc, and hand that in as your research report, it's very difficult to include real-time Python code that can be run at any given moment. This is a tool that lets you do the both, lets you do whatever you need. Okay, so this is how to get started and how to start using Jupyter notebooks. Now, this, as I said, is how to do it in your browser. You can do the whole project that way. You may find it easier to simply install onto your um, own computer and run it there. Okay. If you do that, it can be a little daunting, but what we'll do is we'll show you how and we'll work through it. It's a little different for Windows and Mac. But go back to Jupyter.org. Scroll again. It's about a third of the way down the page. Don't go with Jupyter Lab. You don't need that. It's a tool that's way more than we need. And voila, which is the other tool on this page, is again not what we need. You just want Jupyter Notebook, the classic notebook interface. If you want to run this on your own laptop, you click Install the Notebook. It takes you to the instructions. Again, skip the stuff with Jupyter Lab. And it will tell you install the classic Jupyter Notebook with the command pip install notebook, and to run it, type Jupyter Notebook. And hopefully this will work correctly the first time. But on a Mac, I will open a terminal window in Microsoft. This is a PowerShell. If you have installed Python on your laptop, you should have pip. It may be an issue of needing to find the path. If you're having a problem, we will work through this in class next Monday on how to deal with pip installing the notebook. But you simply type what it tells you on the website, pip install notebook. And we'll see if we get the error message. Now, in my case, this is already installed. So it's running through a whole bunch of things that said it's already there. You will see something similar to this as as Python installs the package for you. When you're all done, you have no error message. You will be back to your terminal prompt. And now I just type Jupyter Notebook, and it will start up. Usually takes a couple of seconds. And it opens a new tab that looks like this. You can see this is a little similar to what you get running it in the browser. So this is what I get running it in the browser. This is what I see running it on my own laptop as a server. Okay, it's a little different. What it's giving me an option here is anything that can be a Jupyter notebook on my computer. It's giving me an option. Hey, do you want to just start with this? No, I don't. New Python 3. This is my new notebook. It takes a bit to start up. This is now running on my laptop. I've got everything here locally. And personally, I find this easier than doing it in the browser. But if you want to do it in your browser, that's fine too. Again, we'll give it a name. First Jupyter Notebook. .ipynb. It will automatically assign the .ipynb extension for you, but again, I kind of like to put it there myself. And here we have a new blank notebook with one cell. Okay, and we can do whatever we want here. Def, recursive, factorial, num. If num equals 1, return 1. Let's make this a little bit more robust and say if it's less than or equal to 1, return 1. Else, return num times recursive factorial of num minus 1. Okay. And this is a Python cell. Okay. If we run it, it doesn't do anything because it's just a function by itself. It hasn't gotten any data. Now, let's do this. Okay. Let's say in our main program, x equals 5. y equals recursive factorial of x, print y. Now, if we run this cell, because cell 1, when we look at numbers over here, this is cell 1. Because cell 1 had already been run, Python knows that that function exists. Okay. Python knows that that function exists. So when I called the function here in cell 2, Python worked perfectly. We recursively calculated that 5 factorial is 120, and life is good. If I wanted to change x to 10, run this cell again, because recursive factorial has already been, this cell has already been run. The function call is known and there's not a problem. If I wrote this cell but did not run it, and then I ran cell what's now 3, it changed the number because I edited it. Because I edited the cell, the number changed. If I tried to run this before running 1, then I would get an error message that said this function is not known. But as long as I run this, life is good. If I want to, I can always guarantee that I can run all cells by simply saying run all. And that way I am never going to have a problem of, oh, I forgot to rerun a cell. So it's something that gives you a lot more control over your Python program. It makes it a lot more, it makes it a lot more modular, sorry, is the word I'm looking for here. It makes it a lot more modular. You can run parts of it. You can run all of it. You can isolate the work you're doing. You can add things. You can make errors. You change errors. You can debug. It really gives you a lot of power to work independently. Okay. So again, this works exactly like the doing it in a browser. The interface is just slightly different. I click in this cell. I say insert cell above. Here, if you look, these are the moves. These are the copies and paste. You have the things. I can click insert cell above. Make this a markdown cell. Markdown cell. This is a markdown cell when you're running the notebook on your computer. Okay. And I run the markdown cell and you can see I get the heading and everything else. If I decide I want this to be the first cell in my sheet, I just click up and I move it around or down. If I wanted it to be the last one, I can move it down. I can move it up. I have all the options. So that is an overview on how to use Jupyter Notebooks, which, as I said, is going to be how you do Project 3. We're going to get some data. We're going to write Python. We're going to write markdown cells to describe what's going on. So we're not limited in explaining to the user just through Python comments. We have a lot more power. We have a lot more flexibility to say, this is what we're doing here and why we're doing it. Now, click here to run the Python code and you'll see the real-time answer. If you're doing something in research that does involve data that might change on a day-to-day basis, you want this flexibility, right? You want to be able to run it today, submit it when your professor grades it 3 days from now. She can rerun it with the current data from 3 days from now, and life will be good. You've got all the current data, your program still runs, and your markdown is still valid. Okay. It's a powerful tool. It's not a mainline part of Python, which is why the major sections don't do it. But to me, it's a very powerful tool that has a lot of use all over your academic career and, in fact, professionally. You will find that most organizations that are doing code development, that are doing Python work, that are doing research, these are all over the place. If you've done an internship, you might have run into this. You might have run into Jupyter Lab because as I said, it's way more than Jupyter Notebook, but you will see something like this. So that is your background, and that's the material we need for get started on Project 3. I hope everyone has or has had, depending on when you watch this, a uh, very nice Thanksgiving. And we will be back in class on Monday, the 28th. And I will see you then. If you have any questions in the meantime, feel free to contact me. I will be checking in off and on over the Thanksgiving break. So thank you very much.